For number 8, we have to set up 3 different proportions, which is just 2 equal ratios, and solve for x. Then we're going to pick one of them and actually solve them. So if I look at my 2 triangles, I have a smaller one, a larger one. And in order to find x, you could do it a couple ways. So you could start with the smaller triangle first or the larger. If I start with the smaller, I'm going to say x relates to 8 and side length 4 relates to 16. So writing that in a proportion, x relates to 8. So I went smaller triangle, bigger triangle. So I have to go smaller triangle, bigger triangle. 4 relates to 16. For the second one, I could use the bigger triangle first. And it doesn't matter what side length I choose, either the 8 or the 16. So I'll say, in this case, 16 relates to 4. So bigger triangle, smaller triangle. So again, bigger triangle, smaller. 16 relates to 4, 8 relates to x. For the last one, I'm going to stick to just one triangle for the top and bottom numbers. So I could say x relates to x and 4. X relates to 4. And then 8 relates to 16. So solving any of these will get me the exact same answer. So it doesn't matter which one you choose. Let's choose number 1. So 8 over x is equal to 4 over 16. You could reduce 4/16 if you want to, or just cross multiply. They're pretty small numbers. So 8 and 4 gives me 32, and that's equal to x times 16 is 16x. How do I get x alone? Divide by 16. So x is 2. Why isn't my answer reasonable? Well, I could check both the second and third proportions and see if I get the same answer. I also know that x has to be smaller than the 8 since it relates to side length 8, and it is definitely a smaller side length than that. And I could also find the scale factor of the picture as well. What do I multiply 4 by in order to get a new side length of 16? Well, 4, and then my new side length of 2 times 4 gives me the 8.